I'm Michael West, Technical Product Manager with VMware. This is an overview of the Harbor Enterprise Container Image Registry, which is part of Pivotal Container Service, or PKS. Pivotal Container Service provides support for the configuration and deployment of Harbor, as well as integration with Kubernetes clusters deployed through PKS. Harbor includes role-based access control. Image repositories are organized into projects where administrators can define access control and image replication policies. Harbor supports external LDAP authentication, including with Pivotal's User Account and Authentication Server, or UAA. Developers can build and push images to their projects based on their access policy. Harbor comes with an integrated notary server. If the content trust policy has been enabled on a project, developers can sign their images so that its provenance is verified. Harbor will restrict access to images that have not been appropriately signed. Harbor is integrated with open source Project Claire to provide vulnerability scanning of images. When vulnerability scanning is enabled, data is regularly imported from a known set of sources and correlated with the indexed contents of images in order to produce lists of vulnerabilities that threaten containers created from the images. Scanning can be done at image upload and at defined times during the day. Harbor can restrict access to vulnerable images. Kubernetes applications deployed on clusters created through PKS receive the benefits of image signing and vulnerability scanning enabled through Harbor without any additional configuration. Let's jump in and see how this works. Within Harbor, images are organized into projects. We have a project called Library, which contains a set of repositories. If we expand one of those repositories, we see two tagged images. Vulnerability scanning has been enabled, and the results are available in a visual tooltip. The common vulnerabilities and exposures, or CVEs, are grouped by severity level and by color. Here we see a significant number of high threat level vulnerabilities highlighted in red. Clicking on the image tag provides a detailed vulnerability report. Each vulnerability is listed with severity level, the package and version containing that vulnerability, and the package version that contains the fix. Now let's see how to enable content trust within Harbor. Let's start by creating a new project and enabling content trust on that project. We are going to first push an unsigned image to our new project and verify that it was created in Harbor. Unsigned images are noted with a red X. In order to create signed images, we must first enable content trust on our Docker host. We do this with two environment variables. When we push the image, Notary generates a set of keys, and we are prompted to enter a passphrase in order to sign the image. Signed images are noted with the green checkmark. Let's try to deploy a pod from our unsigned image. We see that we get an image backoff error, and if we describe the pod in more detail, we see that there's a problem pulling that image because it's unsigned. In order to deploy a pod from a signed image, we must first create a secret that contains the Harbor credentials. We reference those credentials in the deployment file. We see that our pod is now running successfully, and if we drill in further with the described command, we can see that the image was pulled successfully from Harbor.